I didn't hear anything. Did you guys hear anything recording? No, okay. We got this. Why is it? It's okay. We're gonna try it. We're gonna try it, guys. Is it save mode? Let's see. It has a little red thing that's flashing right here. It says pause. And then it says pause. So it should be recording. Yeah, hopefully it's recording the voice too. All right, class, let's go then here. So we did the first ones here. Sorry, Caitlin and Wyatt. We started without you just for a little bit. But here's the rest of it. So 57, we're going to do this on calculator here. So the nifty calculator right here. We're going to go close this off. And now we have two things here. For number 17 on the homework, if you guys go back to 17, it's sine theta minus 3. So I got myself sine theta, sine of x in this case, minus 3. But then it's no longer a 0 anymore. It is just 5 sine theta. Oh, that's crazy. That's going to be interesting. Okay, now I just need to know, especially with calculators, you need to know if your degrees or radians, or you may be off. And you're just verifying your answers here. So for the following, find blah, blah, blah. Use a calculator to approximate the answer to the nearest tenth of a degree. Okay, we're degrees. So let's go like this. Let's go zoom again, zoom, and we go trig zoom. Because it's just a fast way to get our screen already. Whoa. All right, and you guys tell me if you guys got those or not. We're looking from here, right? Here to here. That's what we're looking at, right? Because it goes to negative 360. Who cares about negative 360, right? So I got myself, let's see, intersection points. They hit right here, is that right? Right there? And they hit right here. The only thing is, notice on the screen, it's like it's way at the bottom of the screen. We good? So what I want to do is I want to extend this down a little bit further. So I think, let's go to window. So notice your y minimum is -4. Are we good? Let's go y minimum be like -8. And let's just see how that works. Let's see if that helps our cause here. Oh, nice. Is that a little nicer there?
It's like a pen or something.
Pen.
Each one is like a little pen.
Oh, with the ballpoint pen.
Yeah.
Uh-huh.
Ballpoint pen.
Okay. It just opens up like a little fat at the bottom now. Okay. So we're going to try to find this guy here. This guy now is called an intersection point. Is it good? That's an intersection point right here. So here's what we do. Important now is we're not finding zeros anymore. Zeros are where it crosses the x-axis. So good? But here we want to find the intersection between two graphs. So here's a little bit different than we did before. We go second, calc, and guess what? You guys tell me. Which one do you think we're going to pick now? Intersect, number 5. So you have two choices here. You can either go down like this on your arrow keys and click enter. Or, yeah, you could just be up here. Just press 5. So much easier. Boom. Then it says, which one's your first graph? Well, we only did y1 and y2, right? So we can just press enter. It's going to jump to the next one, which is right there, which is y2. That's enter. And it's going to do the same thing again. Oh, it says guess, right? So we're going to do here. So with your arrow keys, you're going to have to go, and you just get close to your answer. The closer, the better. But you just don't want to be like right in the middle between two intersection points. That's the important part. You want to be just closer to that one. Because what it does, it kind of forms a little bubble and it starts figuring out where they are. So press enter and you're good. All right, you guys, real quick, is that the intersection point that you guys got? 228.6, is that right for number 17? Okay, and then let's do the next one real quick here. So second, calc, number 5, which is intersect, and that's kind of cool. You notice it just kind of, it's kind of where you left off. We're good? So you press first curve, yes. Second curve, yes. Yes, now we use our arrow keys just to go closer and closer to the next point right there. That's pretty close. Enter. How about 311.4? Is that right for number 17? Sweet. Okay, so we solved this now algebraically initially, and now we're solving it graphically. Okay, back to our number here. Number 65 is the next one. 57 is done. 65. All right, let's see. If a projectile, so let me read it here real quick here. Projectile, such as a bullet is fired into the air with initial velocity of v and initial elevation angle of theta, then the height equation, I guess I'm going to write this down now. So this is 6.1, number 65 is the honors question. So it says when the height of the bullet, so something like this, something fires off the ground, it goes like that, it comes back. It says the height equation is in terms of gravity taking over and in terms of the velocity which it was shot at and the angle. Did you guys see this formula in physics?
What was that one?
Yeah,
Yeah, we definitely see it in the I
Finish.
you know what
it looks
link squared was
similar.
was like the fourth one. Oh, the big four? Yeah. Yeah.
Cool, okay. So I'm going to go to this. It says formulate the equation if V is 1500 and the angle measurement is 30 degrees. So in this case, V gets replaced by 1500 and then that's T and this is sine of 30. But real quick here, I don't think that's the answer back of the book because what is sine of 30 degrees? Anybody? Unit circle sine of 30 degrees is 1/2. So really the equation, if we're going to put this together, it's 1/2 of 1500, which is 750. So there's the equation, really. You get rid of the trig function. You just simplify it as much as possible. You're good to go. Then 67 is actually part of it. 67 says use this equation you found in 65 to find the height of the object exactly 2 seconds after being fired. 2 seconds after being fired, we just stick in a little 2 right in here. And anybody with a calculator? Did we have to do 67?
I don't think so.
No, we didn't. 69. There you go. That's what I was messed up on. Never mind. We'll do 69. But that's cool. If you did 67, you wanted to. You were just plugging it in.
The 7 looks like an arrow. Kind of cool.
That's cool. 61. 69. Is that right? 69. Okay. 69. Find the angle of elevation of theta of a rifle barrel if the bullet fired at 1500 feet per second takes 2 seconds to reach a height of 750. Give the answer. Oh, now we're actually solving it here. Hold on.
Definitely not.
Sounds fun.
Now I got back to this equation again. And then the question now is Vt sine theta. So find the angle of elevation. So we need to find theta. If the rifle barrel, if the bullet fired at 1500, oh, we got the same equation here. This is 1500 feet per second. And then it says it takes 2 seconds to reach a height of 750. Okay, so now we got ourselves what we need here. 750 is my height. And it took 2 seconds to get there. I need to know what my angle of elevation was to make that happen. Kind of important. All right, help me out here with some math here. So I'm going to go, that's 32. That's 3,000, is that right? And what should we do next? Subtract 32 or add 32, sorry. Add 32 both sides. So 782, is that right? Whew, I'm not sure if that's a big angle or a small angle. Let's see. Divide by 3,000. And let me move this somewhere else so it doesn't bug us. Divide by 3,000. Okay, so this one now. So I got myself sine theta is equal to 782 over 3,000. Let's use our calculator.
I don't want to do that in my head.
Not today. Anybody on the calculator, make sure you're in degree mode. Oh, I have a calculator. I can do it too. So, got my sine inverse of 782 divided by 3,000. Area okay with 15.1? Awesome. There it is. And then question is did Bob agree with us? Is this 15.1? Does it mean to know what Bob said?
I didn't check
We
with Bob
done.
said.
We didn't check with Bob. Yes, I heard a yes.
Yeah.
I did like 5 or not over.
Interesting. Okay, did I do something wrong in my calculation? We're off just by a little something. Did I subtract some? Yes, I did subtract something incorrectly here. No, I added correctly. That's 758. Interesting. Maybe Bob is off, you know? Sometimes he does his work like 2 o'clock in the morning and gets tired.
Sure.
So that's just the way it is. Mm-hmm. Okay, you guys talk to me. Are we done with 6.1? Yes, okay, 6.2, 37. 6.2, 37. Just jamming. 37. It says for the equations, find all degree solutions from 0 through 60, right answers to nearest 10th. Use a graphing calculator to verify. Oh, exactly what we're going to do. We're going to solve it, and then we're going to use the graphing calculator to verify. So legit. 37. We got to solve this one. 7 sine squared theta minus 9 sine 2 theta. Oh, interesting. Sine cosine. Never mind. Real quick here. Sorry, that should be cosine. There you go. That guy should be changed into cosine. As I'm checking here, 7 sine squared theta minus 9 cosine 2 theta. Okay. I got myself a problem. The problem is I have one trig function that's squared called sine, right? But then my linear function is cosine. I cannot have that. If I'm going to do this, I have to have both the square term and the unit term for trig functions to be exactly the same. You help me out. What should I do?
Use the Pythagorean theorem.
Yeah, not. Oh, yes, Pythagorean theorem. That's right. Let's see. I can change this into cosine. 1 minus cosine squared theta. Is that true? Can I do it like that? So by the Pythagorean theorem, I can change that into cosine. Cool. So 7 minus 7 cosine squared theta minus 9 cosine. Oh, hold on. Now I see a cosine 2 theta. I don't like that. I want these guys all in unit values of my angle. So can you guys give me some kind of substitution or identity that'll change cosine 2 theta into like just regular theta? And then also, yes, this one here. And also hopefully is in terms of cosine.
2 cosine squared theta minus 1.
And it is 2 cosine squared theta minus 1. Everybody okay there? Man, we had to use 2 identities for this. Okay, so now we got 7 minus 7 cosine squared theta minus, what is it, 18? Is that 18 cosine squared theta? And don't forget to got this little 1 here. So negative 9 times negative 1 is a positive 9. Okay, let's put this all in order or combine like terms. Oh man, this is a difficult one, guys. So negative 7 squares of cosine and negative 18 squares of cosine make negative 25 squares of cosine. Are we good there? And I got myself 7 here, and I got myself 9 here, so that makes 16. Everybody okay so far?
Yes.
Okay, so now notice, oh, this is good, guys, this is good. Notice we only have one trig function called cosine, right? And we only, it's a coefficient. So notice what happens here. Since we only have one term that has the trig functions, we can solve this by moving the things over. I'm just moving things over to this side here. I'm going to just subtract 16 from both sides, right? Normally how we solve for x. Eventually, yeah, but you got to move things over first. You guys get the minus 16 here. Divide by negative 25.
Oh, and those are all
Oh, those are actually perfect.
Oh,
Hey, I love it. Love it when it's beautiful.
and it's both negative, so it becomes positive.
Oh, let's see. When we do the square root, right? When we do the square root here, we got to put a plus or a minus. So now we're looking for this one. Cosine theta is equal to square root of 16 is 4 and a 5. Okay, guys, now this is the fun part. Fun part, here we go. So I have to use a calculator to find my answer. We good? So whenever I use a calculator, I always use the positive ratio. We good?
Mhm.
And that gets me my reference angle. We good? So I need to know, oh, hold on. I need to know when cosine is positive and negative. Isn't that all 4 quadrants? On your calculator, if you guys can, just write this here. Oh, sorry, I should write this here. So you're going to put theta, and you can put a little hat for theta. And you're not going to use the negative, you're just going to use the positive of this one. So anybody can give me cosine inverse of 4/5. Make sure you are in the angle measurement of degrees.
36.
36.8 is perfect. Okay, so 36.8. Anybody second that real quick here?
Second emotion.
Okay, so what we found is we just found the reference angle in quadrant 1. That's what we did right there. That is 37.8 degrees. Now the question is this. What are all the other angles in all the other quadrants? So if you go over here, tell me if you guys agree here, isn't this going to be 180 minus 37.8? So anybody have a calculator here? Give me 180 minus 37.8.
143.2. Okay, the angle was 36.
Oh yeah, thank you so much. Sorry, 36.8. See? Someone seconded it, but didn't. 36.8, we good? Changing as we go here. 36.8. Cool, thank you. And now it's going to be what? 143.2. Awesome. In quadrant 3, what happens in quadrant 3 is what we do is we take 180 and we add to the angle. So what is 180 plus 36.8?
216.8.
Okay, I'm going to go with 260.8. Anybody want to second that? Sweet. Okay, and the last one, going all the way to quadrant 4. Quadrant 4 is now 360. 360 minus 36.8. And what is that?
23.2.
323.2. Anybody second that? Sweet. Okay, awesome.
Calculator.
Okay, so that is the algebraic way of solving it. We good, guys? Now the question is there a geometric way of solving it? Yes, absolutely. Let's do the geometric way of solving the same exact thing. So jumping to our calculator, we're going from 0 to 360. We're going to go y equals, and then what we do is we have to erase all these guys. So press the little clear button. And then we're going to go with, oh, now we have to square the sine function, guys. This would be interesting. To square sine, in our paper, we write like a quick notation, right? It's sine squared of theta, right? But on the calculator, you can't do that. So we got to do this here. You got to do 7, put into parentheses, and it's going to be sine. And then notice you have another parenthesis that opens up. So, oh man, a whole bunch of stuff here. So we're going to close off the first one. That's for the sine function. We good? And we close off the second one in order to prepare it for squaring. So this is my square right here.
Preparing for squaring.
Minus 9. And now we got a cosine in our hands. Cosine, and then that angle is 2 theta. So it's 2 times the x. Close it off. When you press enter, that's what it does, right? Sheesh. Now, do you guys have, my screen is, let's see if I can actually, can I extend the screen? No, I can't. That's no fun. Okay. Are we good there? You guys following along? Those that following along on the calculator, are we good there? Like with that one? Okay. We're going to graph this. And this time we're going to solve it for 0. That's what we want to do. So zoom and trig zoom. Whoa. So 1, 2, 3, 4.
Markers as well.
So let's do this here. let's go up and down. We good on it?
Yeah.
Whoa.
So let's go like let's go window.
That one.
First of all, I don't need to go to negative 360, so I'm gonna click 0 on this one. I'm actually gonna go to 360 because I want to see what it looks like every 90. And then this would be negative 20 to positive 20. That's what I would do because I want to see as it comes up and goes down. We're good?
I have that.
All right, waiting a little bit here for those that follow along with the calculator. And graph it. Let's see if it looks. Oh, doesn't that look a lot better? Okay, so we're gonna find zeros again, 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 and again.
How is that?
Oh no, right there. Just made it nice.
Okay.
Went from 0 to 360. Every 90 is a notch, right? And then instead of going negative 4 to positive 4, I went to negative 20 and positive 20. So I expanded my Y window quite a bit. And graph it. Okay. Not going to take too long because we're going to do all 4 of these here. So I'm going to go second calc. We're finding zeros now this time. But that's exactly what we did initially, right? It's number 2. Doo-doo. And here it is. Oh, man. I got to use my arrow keys. I got to be on the left side of this. Left side. Right over here.
Just
Press enter. And then you got to just go over to the next side. Tell the calculator that's only where I want you to look, nowhere else. Click enter. And did we get 36 point? Oh, guys, look at this. We had a 36.9, not 8. Someone didn't round, but I won't say who. So it should have been probably 36.9. So you're going to be off by a little bit here. But is that one of the answers we got, right? And then someone seconded it without verifying. They just like, I second the motion. I remember that.
Oh, no,
So then we go with the next one here. So we're going to go, let's just find 2 of them here. So second calc, finding my 0, which is number 2. And I have to be on the left side of my next 0. So I got to just be, before crossing it from the right to left, I stop, press enter,
right above the first one and just
and I go,
that's it.
press enter. Say again.
So you could be like right above the first one.
Yeah, true. Yeah, as long as there's no other zeros that are crosses between the 2. And enter. And how about a 143.1? We good? We had a 143.2 because we did not. So, okay. Are you guys good? Oh, and then notice real quick here. Look at this. It says a negative 1.7 e to the negative 12. Did you guys ever see those on calculator before?
yes.
That's cool. It just means this. Yeah. What in the world is a negative 1.7 e to the negative 10?
Oh, well,
It means this.
definitely remember that.
Uh-huh. A negative 1 point. Whoa. Uh-huh. Gotcha. Here it is. So what your calculator does, it just calculates a whole bunch of number crunching numbers, right?
Yeah.
And it gets close to it. Sometimes it gets stuck because it'll go above 0, below 0, above 0, and it says, okay, I quit. And this is what it got. This is how close it got to 0. So that e thing, majiggy right here, it just means times 10 to the exponent of negative 12. So if I were to put this on the calculator, so negative 1.7, and I were to move this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's the number that I'm looking for. So I'm looking for 0, 1, 2, 3, 4, 5, 6, 7, 10, 11. Okay, guys, is that pretty close to 0? Yeah, so that's the closest it got to 0. So just stop there. I figured 12 decimal places, that's pretty good. Okay, still jamming, guys, with the remaining time that we have. Let's go a little bit faster. 6.2 is good. 37? Let's go 45. 45, I thought that was kind of pretty cool. Is 45 a regular or honors question? Honors question. I thought this was kind of cool. It is from physiology. Anybody going to the medical field or something like that, this is kind of cool. It says this. I just thought it'd just be kind of cool just to sort of see it. So we have veins in our bodies, right?
Just
Oh, cool. Okay. Oh, awesome. Okay, so then the way your cardiovascular system branches out, that's what this is about. It says in the human body, the value of theta makes the following expression. 0 is the angle at which the artery of the radius r will branch off for a larger artery of radius r to minimize the energy loss due to friction. Show that the following expression is 0 when theta is equal to this. So again, it was a little bit brainy, right? But I thought like that's such a cool thing. So this is r to the 4th cosecant theta squared of theta minus r, big R to the 4th. And it's cosecant. What? It's like your arteries, no trigonometry. It's kind of cool. Okay, it says this when your arteries they branch out right to smaller arteries, it actually depends on the size from the large one. It's a proportional from the large artery to the smaller artery, right? Because if it's a small artery and your artery system is wired in such a way that this angle here, this little theta angle right here that is formed, it's maximized, it's made to minimize the amount of friction that your blood has to pass through in order to pass to each one. So it's like super optimized. So it's the least amount of energy for your blood to get to your capillaries. So we good? So the angles are perfect when you look at all the different, each time it branches out. Now this could be a lot bigger, right? This could be a lot smaller, right? And because of that, that angle will change. So based upon how big this is, and how big this is, actually this should be a radius, right? And how big this is, the angles change, but they still minimize the amount of energy. We good? Cool, okay, anyways, let's go with it. So it says, show that this guy equals 0 if this is true. R to the 4th over big R to the 4th. Okay, and it somehow has to be 0. So let's do this here. We have to substitute stuff.
Substitute. Oh, it's the cosecant and the. Oh no, you substitute. Oh, never mind.
Yeah, it's cosecant squared on the first one, right?
Yeah, but cosecant is equals to what is that? No, that's cotangent. Right. Cosecant. Sine. No,
Let's see. Try to see if this works out here. Let's see. Let's substitute something. Yeah. Let's see. This is where we got to substitute right here, right? If we were just to take this and multiply, let's just gonna do a little bit of work here because we got to plug it in somehow. True. If we multiply both sides by big R to the 4th, like this, so that means big R to the 4th cosine theta is the same thing as little r to the 4th. Everybody agreed there? Okay, so then what we're gonna do is we're gonna substitute this guy here. I think it should work out. I don't know. We're gonna substitute these guys. We good? So little r to the 4th now is going to become big R to the 4th cosine theta. So let's see if this works out. Big R to the 4th. So this little piece right here. This little piece right here, we're going to substitute a big R to the 4th cosine. Come on. Cosine theta. And we're looking at time with a minute left here. I'm going to try to finish this off. Boom. And we got ourselves big R. And we got ourselves cosecant theta, cotangent theta. There it is. All right, some trig functions here. Let's see. Let's make everything into sines and cosines. Anybody help me out here? What is cosecant? 1 over sine squared theta. Perfect. Big R over here. And this is cosecant is 1 over sine. And then cotangent is cosine over sine. Is that right? Oh, cool. Look at this. That means this is just all of this big R to the 4th times cosine theta over sine squared theta minus big R to the 4th. Then on top we have a cosine. And on the bottom we have two sides that are multiplied together. And if you have one thing that's exactly the same and subtracting another thing that's exactly the same, the answer is 0. 0. We good? Are we good there? So we've proved the optimization of arteries does happen. Certain things.
I don't like blood or needles.
Yeah, mine are
Just
not trying to
It's not.
I need to, but
No,
buy them
it's like-
myself.
No, this